So for those who now logging in, right? So here we have y is 3x squared. This is a curve, which we're trying to linearize it and write a curve in the form of a straight line. So in order for us to linearize, we could take logs on both sides. So we log here, and we log here, and we simplify it until we get something in the form y is mx plus c. So your y is log y, x is log x, gradient is r, log p is c. So if I had to plot this graph, I would plot a graph of log y versus log x. My gradient will be r, and my y-intercept is c. All right? So I kind of did that a little while, and I gave you an example to do. Let's see what he came up with. I tell you, come on the board here now. Come on, tell you. Right, so actually your parents are going to make you watch this video, right? And you will see how she will listen in class, right? Actually, you hear that, sir? Right. What to do here? So we started with y is equal to ab to the x. Really and truly, the question is going to ask you, given y and x, solve a and b. Right? So you have to figure out how to solve a and b using the graph, of course. So what you will do is you'll take logs, right? Take logs, and you'll get log y is equal to log ab to the power of x. Richard? Okay, yes, Richard? The nice job, Maria. Richard, you there? All right. Right. Question here earlier. This x, is it above the b or the a? B alone, right? So when I split this up, I'll get log a plus log b to the x. That's okay? When I split it up. Now I'll get log y is equal to, bringing the x in front, log b plus log a. Correct? What do I plot on my y-axis? Log y, right? Which one here am I going to plot on my x-axis? X. Because it mustn't have any a or b in it, right? So this is my x, so therefore this is my gradient, this is my y-intercept. All okay with that? Watch your rule again, right, Atelia? Oh, yeah. Okay. Right? This must, y mustn't have anything besides the variables in it. Right? Gradient cannot have x or y in it. So therefore, I am going to plot. My graph will be log y versus x. My gradient will be log b. My y-intercept will be log e. So Ford, if I gave you x and y values, right? Do you have to log the x values to plot this graph? Do you have to log the x values to plot the graph? No. Right? Because here's x. Do you have to log the y values to plot the graph? Yes, because you have log y here. Follow that? Follow that? Next with Kilo. What's the name again? Kishar. Follow this? Right? I really know how to make a plot a graph, right? But we already have graph before. So let's focus on the linearization, right? Okay? Right? But that's the hard part. You just to plot the graph and find gradient. Okay? So let's practice some more linearization. Any questions online? Any questions online? Flores, are you okay? Shannon? Esther, are you okay? All right, so I'm just going to give you a few more examples because here's what all is. Not all the time, you have to take logs. Sometimes you can rearrange it. All right? So let me give you an example where you can just rearrange it. Actually, I gave you this already. All right, what is here? If you see something like this one here had two terms alone, one here and one here killer. One here and one here. Whenever it's two terms and you have multiplication or division, most of the times it's logs. But on terms you have here, 1, 2, 3 different terms. In a case like this, you have to rearrange it. Right? So let's see if we can rearrange this in such a way that we can separate the variables and separate constants basically. Watch this here. If I wanted to plot this, this is y, this is m, this is x. But you see the problem here? The c value has a x in it. That's okay? You'll see enough? If I try to plot this here, I'll have my y, so that's good. I have my gradient, I have my x. But look at c. C has this x value in it. We don't want that. We have to find a way to get rid of it. So open to it is. So this young fella here sit down there and he said, this young fella said to multiply by x. Right? So when you multiply everything by x, you'll get xy is equal to ax squared plus b. Now looking good? Let's see if it satisfies all the rules. If I were to plot this as my y, does it satisfy the rule? Any a and b here? Any a and b here? So it satisfies the rule. It could have an x. It could have an x. Right? But it can't have a and b. What about here? Any a and b in x squared? Nope. Any x or y in a? Nope. Any x or y here? Nope. So now I could go ahead, take my values, plot xy, and plot x squared. I'll get a straight line. Gradient is equal to a. Y-intercept is b. You see that? While you're writing, suppose I give you this kilo. Suppose I give you this, and I tell you to find out this. You can do that. Suppose I give you this, and I say, well, kilo, come on the board and find out this. You can do that. Huh? Possibly. Kilo, if you can do that. If you could go from here back to there, what you would do? So this will be a, this will be a, this will be a x, and this will be a. So you just plug in it right back in here and then divide it together. And so I'm gonna give you something to try, right? So one line, if I give you something looking like this and ask it to reach here, just move backwards. Y, x, gradient, y-intercept. Copy down. Let's go again. Check and see if that needs to linearize and linearize this is number 4. Check and see if it needs linearizing. Right, so you have to tell me this, right? I want to see that word here. Everything goes. You might put a sketch. Yeah. So what do you think, Daniel? What do you think? Do we need to linearize this?
I don't think we are just
Just rearrange it. And this is your, this is your, this is your, this is your. So this is already a straight line. Right? No longs, no anything. Good job. Richard, you got that? Christian, you got that? Yeah, you got that? All right. I'm gonna give you the reverse now. And I want you to tell me what the equation is, right? Try that in. Ariana, do you all get any lag? Like between me talking and writing? Any lag? No? That kind of fixed part. Right? So I'm going to reverse to number 5. That's minus A here. Minus A. Try and simplify it and make it look a little nice. Did you finish? You don't get you? Try and make it, you can leave it as fraction. Don't put it to the minus one. Let's see what you got. All right, so it has to be in the form y is equal to mx plus c. Y is 1 on y. Gradient is minus a on b. X is 1 on x. Y-intercept c is 2 over b. All right, what we could probably do is multiply everything by b. If we multiply everything by b, we will get by is equal to minus a on x plus 2. Okay? You can bring it across and make it look a little nice, but so you'll get b over y plus a over x is equal to 2. That's probably the best we could do. Right? Anything else to make it look bad. But if you want, and you're okay with, and you want to get rid of the fractions, you can multiply everything by xy. And you will get bx plus ay is 2xy. Right? That would get rid of all the fractions and make it look nice. But it's not looking so bad. Looking okay? Yeah. That's not looking so bad. Any questions online? Sahara? Shannon, you working out these things? Quinn? Any questions? Samir? Eden? Are you okay? Eden, you okay? All right. I wanted to message the answers online. Here's what I'm going to do now. I'm going to give you some numbers. Right? I'm going to give you an equation, and I'm going to give you points on the line. No, you don't have to plot. Right? I'm going to give you points on the line. If I give you 2 points on the line, what you can find? If I gave you this point and this point, what can you find? You could actually find the gradient, and you can figure out the y-intercept. So it means that you can figure out these two things. All right? So I'm going to give you one here, and I want you to find the equation y-intercept. Try this, please. And this is the graph for this. This is the graph for this, and I want you to figure out how to get A and B. Take your time. I'll already show you how to figure it out. Right, not the equation. Right, so I hope you remember when you linearize this, you got log y was 3 log x, right? This was your y, as you can see there. This was the x, so the gradient is b, and the y-intercept is log. Right, take a 2 minutes again. So the objective of your whole exercise is to find the end. How again b kilon, b is equal to what? What's equal to? B is the what? Gradient. So if you find the gradient here, you find b. Right? So you have to figure out how to get b. Okay? So the gradient is b. Okay, last minute, and then I'm going to do it. You got it? You found the gradient? What do you need? Find the gradient. At least get to that part. Gradient is b, so find the gradient. Right. So what we got for gradient? Right? If you're confused, take a look here. gradient is equal to y2 minus y1, x2 minus x1. So I got minus 2/5. That's okay? And we know that the gradient is b, so we're done. B is minus 2/5. That's okay? But here's the problem now. How are we getting a? All we know is that log a is equal to the y-intercept, which is how much? Y-intercept is 2. Right? So how do we go from log a equal to 2 to figure out what is a? Carry across, very good. Carry across the log. And what's the inverse of log? I never teach. I should do that way. Never teach before. Never.
I was from.
So LG means what? LG means what? Log to the base. So could we go from here to exponential form? I never teach before. I never teach before. So it's carry across, bring up the 10, carry across 2. So you'll get 10 squared. Right? So the inverse of log is 10 to the power. Okay? But then again, yours and never teach before. Okay? So watch here, last step. Last step, we know A and B, so we can write this equation. So therefore, the equation is y is equal to 100x to the minus 2/5. All right? Right, let's check out online. Online, you're looking what happened there? You will close to it, Katrina. Right, you can follow what to do now, Esther, Ariane. Christian, are you okay with that? Huh? What? Right? Let's try our next one. This time I'll give you less information. Same graph though, same graph, log y versus log x. Same shape. Here's 0, 4. That's 0, 4 there, right? And here is 6, 2. Same shape. Find y in terms of x. Find y in terms of x. Right? Of course, you'll identify what it looks like, right? Find y in terms of x. Okay, find the y step on there. So the coordinates are, yeah, it's blurry. Yeah, 0. Here is 0, 4, and here is 6, 2. 0, 4, and 6, 2. Right. So there you go. Just like, well, that's the equation matter what love is. Or like how I give it to you there, y is equal to something. I don't want the love. All right, so but that's good. You all figured out up until here. Log y is equal to m log x plus c. I like how you all figured out there, right? But remember, this could be simplified into what? Same thing, right? I don't have to tell it up because what? Same y and same x, and same y and same x. So your objective is to find a and b. Okay, just like that, just like that. So you're basically following that example. All right. So yes, you should figure out your gradient and you should figure out your y-intercept. Right? What was the gradient? So 4 minus 2 over 0 minus 6. So negative 26 or negative 2. So we know what b is. B is negative 2. Go back and find a. Go back and find a. We know what b is, right? Go back and find a. Just like this. Just like this. A y-intercept is c and solve for a. Right, but if you all wrote it like this, that's very good as well, right? Just remember that that has the log. Right, so we got what? We got log a to be equal to how much? 4. Log a is how much? Log a is what? What's it here? Log a is what? Y-intercept. What's the y-intercept here? 4. How easy that was. So a is how much? Log a is 4. So a is how much? Look at there. What did there? Okay, Shaf. A is what? 10 to the 4. That's it. That's it. y is equal to 10 to the 4 x to the minus 1 0. That's all for the visitors. Let me make it take it hard. Yeah, made hard. Easy. Last one. You can squeeze in one more before I give you one more.
What?
Huh? You have time, we can squeeze in one more and one more. But again, long kahoot today. You can have enough. Now, last one, right? I want y in terms of x, right? So I want you to use all your simplification ability. I want y in terms of x, right? So here's y. I'm giving you the straight line. Here's 1, 5. And here's 3, 11. As I see in this, 1, 5 and 3, 11. 1 over x plus 1. Right. Richard, summarize this answer, please. I want to see what you get for this. So this one, we don't know what the form is, right? Write it, y is mx plus c, and simplify. Make y the subject. Excuse me. All right, so I'll give you a little small help here, right? Let's consider this to be a half. Let's give you a little help because you see, I don't want you all to use y minus y1 and thing. The reason you can't use this is because x is not that. X is this. Right? So the way you use that. So I'll give you a little help with the gradient. Sorry, with the y intercept. Right? So y is equal to what? Mx plus c. Y is y. Gradient is what? 11 minus 5 over 3 minus 1. 6 on 2, 3. So it's 3x plus a half. Right? The reason I have to help you here is because this equation here, you can't find it by using y minus y1. Right? Because this is not, x is this term here. It's a little bit different. Right? So the equation will look like this. Oh, sorry, the equation will look like this. Right? Y is equal to 3 over x plus 1 plus a half. Right? Last one. I tell you one before one more. Yeah. Huh? What homework? Are you going to do no homework? And I even bother. I'm going to do it. All right, let me give you one to. Let me see what you will do. Linearize. Last thing I'll be done. That's the last thing. Linearize this. You tell me what to plot to find A and B. That's the last thing I'll be done. Tell me what to plot to find A and B. Right? This combines everything we did today. Tell me what to plot to get A and B. Yeah, 1.5. Right? A multiplied by 1.5 to the power of minus px. Oh yeah, Malini, last one there. Right? What you're doing here, rearranging or taking log. Why? Because you have one term on the left, one term on the right. That's it. So you're taking logs on both sides. Right? How is your rearranges? Doing away with logs, right? Right, guide me along here, Paul. We shall do it first, we're going to put Malini. And then you watch his pizza. Let me see, one to come to the data. Can you feed it? Kieran, help me out. What to do here? Take logs. Taking log where? Kieran. Taking logs. Taking logs here. I'm taking logs here, right? What do I do next? Separate here because there's multiplication, right? So you'll get log y is equal to log a. Multiply means plus to the minus bx. Is this good enough? What you have to do? So you'll get log y is equal to negative bx log 1.5 log b. And what do you plot? What do you plot? Ford, you do the exact thing, right? This is your y. Right. So what you could do is you could take the x. You could put the log 1.5 here and put the x here. Because this is a value. Right? So this will be your, and this will be a c. All right? So you're plotting log y versus log x. Okay? So that is your linearization. So your homework, do 2017. For your homework, I want